Now the class is single phase AC parallel circuits. Here problems single phase AC parallel circuit problems are saying another example. The example is fourth. Here a mercury vapor lamp unit consists of a 25 microfarad condenser in parallel with a series circuit containing the resistive lamp and a reactor of negligible resistance. The whole unit takes 400 watts at 240 volts, 50 hertz at unity power factor. So what is the voltage across the lamp? Here what is the given data here? In solution 25 microfarad condenser. That means here C is given. It is in parallel with a series circuit containing the resistive lamp and a reactor of negligible resistance. This condenser is in parallel with a resistive lamp and a reactor negligible resistance. So the whole unit takes 400 watts. So here power is given. The whole unit means the power in the circuit is 400 watts and the voltage RMS supply voltage is 240 volts and frequency is 50 hertz at unity power factor. So this 400 watts and 240 volts is the lamp specifications. And unity power factor also lamp specification. So what they are asking, what is the voltage across the lamp? See here XC is equal to, here what is that XC in the solution? XC is equal to 1 by 2 pi Fc, that is capacitive reactance. So 1 by 2 pi into 50 into 25 into 10 to the power of minus 6, that is 27.3 ohms. Therefore here Xc is determined, therefore current IC is equal to, so IC is equal to 240 127.3, that is 1.885 amps. So IC current in capacitor current is 1.885 amps. So W is equal to power formula, P is equal to V8 cos phi. here they written W is equal to Vi cos pi. That is equal to here power factor is 1. So the current is determined from this equation. Therefore, I is equal to W by V. 400 by 240, that is equal to 1.667 amps. From the vector diagram, so in the vector diagram, the given 14.10b, IC leads V by 90 degrees. IC leads here, capacitor current IC leads V by 90 degrees. That means the condenser is present. So here condenser is present. Condenser is present. So only purely condenser, that means pure capacitor. So IC leads V by 90 degrees, and the current I1 in series circuit lags V by pi 1, where pi 1 is the power factor angle of the series circuit. The vector sum of IC of pi 1 gives the total current. Here pi 1 is equal to IC pi I. So that means here tan pi 1 is equal to IC by I. That is 1.885 divided by 1.667, that is equal to 1.13077. Hence, so the angle is pi 1 is 48.5 degrees lag. The applied voltage V is the vector sum of the drops across the resistive lamp, which is in phase with I1, and drop across the coil, which leads I1 by 90 degrees. So here the voltage across the lamp is equal to V cos pi, that is V into cos pi 1. So V is 240 and cos pi is 0.662. So here we'll get the 59 volts. 59 volts. The voltage drop across the lamp is 159 volts. So here the problem is over. Go for another problem. The current in each branch of a two branched parallel circuit are given by the expression Ia is equal to 7.07 sine 314 t minus pi by 4, and IB is equal to 21.2 sine 314 t plus pi by 3. So here in parallel AC circuit, the branch A and branch B currents are given. IA and IB are given from the question. So we are next the supply voltage is given by the expression V is equal to 354 sin 314t. So voltage is also given as this. These equations are instantaneous equations. So here what they are asking, derive the derive a similar expression for the supply current and calculate the ohmic value of the component, comma, assuming two pure components in each branch. Step state whether the reactive components are inductive or capacitive. So they are asking XL, XA and R. Here the solution is by inspection we find that IA lags the voltage by pi by 4. That means in branch 1 current. So minus pi by 4. That means minus pi by 4 means it is lagging. So how many? 45 degrees. IA lags the voltage. That means here inductance is present. Lags means in inductor only the current is lagging. So some information we are getting from this equation. Now IB leads it by pi by 3 radians or 60 degrees. So IB is equal to how much? So plus pi by 3 degrees. Plus pi by 3 means it is leading. There is capacitor is existing. So hence branch A consists of a resistance in series with a pure inductive reactance. Branch B consists of a resistance in series with pure capacitive reactance. And shown figure, see here, this is the figure. This is the figure. Branch 1, branch A or A and XL, in branch B or B and XC. So now, see here phasor diagram. So voltage is reference as taken and current is lagging 45 degrees from the branch 1 and current is leading in branch 2 is 60 degrees. So this is the circuit. Here maximum value of current in branch A is 7.07 amps and branch B is 21.2 amps. So how can we find out the resultant current? In vector representation, the resultant current was x component and y component. Here x component is I1 cos theta 1 plus I2 cos theta 2. Y component is I1 sin theta 1 minus I2 sin theta 2, or otherwise I1 I2 sin theta 2 minus I1 sin theta 2. Whatever it depends on the leading lagging angle. So here x component is 21.2 cos 60 degrees plus 7.07 cos 45 degrees. This x component value of current is 15.6 amps. So now calculate the y component. So y component is 21.2 sin 60 minus 7.07 sin 45. That will give 13.36 amps of y component current. So the maximum value of the resultant current is under root of 15.6 whole square plus 13.36 whole square, which gives 20.55 amps. So now how can we calculate the pi? Pi is nothing but y component divided by x component value. From that, pi is equal to tan inverse y component is 13.36 and x component is 15.6. That is equal to tan inverse of 0.856, that is nothing but 40.5 degrees. It is the leading. Is a leading. So hence the equation is current, resultant current equation is, or expression for the supply current I is equal to, here the resultant current is 20.55 and the pi is 40.5 degrees leading. So I is equal to 20.55 sine of 314t plus 40.5 degrees. So here the resultant current is leading. The resultant current is leading current. Here directly, so here minus pi by 4, that means 45 degrees, the current IA angle, and branch B current angle is pi by 3, 60 degrees. By observing these two, we can say that, directly we can say that, so here pi by 3 is the angle is 60 degrees is more than that of minus 45 degrees. So we can say directly, we can say the current, resultant current is in terms of positive angle only. That means it is leading current. So here that is a technique. From these two currents we can say which is, so which is the what is existing. It is a inductive or capacitive part, we can say. So here the resultant current expression I is equal to 20.55 sine 314t plus 40.5 degrees. ZA is equal to V by voltage by current. That is 354 divided by 7.07. That is equal to 50 ohms. So cos pi A is equal to, that means that means cos pi 1 is cos 45 degrees is nothing but 1 by root 2. So that is cos pi A. So now XL is nothing but XL is equal to, that is cos 45 degrees is 1 by root 2. Now sin pi A is equal to sin 45, that is 1 by root 2. Now RA is equal to ZA cos pi, that is ZA is 50 into 1 by root 2. So RA is 35.4 ohms. Now XL is also ZA into sin pi A, that is 50 into 1 by root 2, that is equal to 35.4 ohms. So now branch B, ZB is equal to the voltage by current in branch 2. So voltage is 354 divided by branch B or branch 2 current is 20.2, that is 17.5. So now ZB is equal to 3. ZB is equal to 17.5 ohms, and now RB is equal to 17.5 into cos 60, that is 8.7 ohms. The same way, similar way, X is equal to, so 17.5 into sin 60, which is gives the 15.16. So now the resultant current is 20.55, which is leading angle 40.5 degrees, and RA XL is determined and RBX is determined from the given data. So this is about this question A and IB, and voltage they given in instantaneous equation. So now go for another example. So what they are asking, see here, observe this one example. A total current of 10 amps. What they given? Total current has given, that is I, flows through the parallel combination of three impedances, that is ZA, ZB and Z3 as given. For Z1, Z2, Z3 also given. So in this problem they take in Z1, Z2, Z3. Question is Z1, Z2, Z3. Here these three impedances are parallel. What they are asking, calculate the current flowing through each branch. So find also the power factor of the combination. They are asking I1, I2, I3 and cos pi. Z1 is equal to 2 minus J5. Z2 is equal to 6 plus J3. And Z3 is equal to 3 plus J4. So here Z1 into Z2, Z2 into Z3 and Z3 into Z1, they calculated. Z1 into Z2, that is nothing but 2 minus J5 into 6 plus J3, that is equal to 27 minus J24. Z2 into Z3, that is equal to 6 plus J3 into 3 plus J4, that is 6 plus J33. Z3 into Z1, that is equal to 3 plus J4, that is nothing but 2 minus J5, that is equal to 26 minus J7. Z1 into Z2 plus Z2 into Z3 plus Z3 into Z1 is equal to 59 plus J2. So now I1 is equal to this equation. So I1 is equal to I into Z2 Z3 divided by Z1 into Z2 plus Z2 plus Z2 Z3 plus Z3 Z4. Substitute I is how much? Resultant 10 plus J0 into Z2 Z3 is 6 plus J33 divided by 59 plus J2, which gives they didn't write here properly. So 10 into 6 plus J33 divided by 59 plus J2 is equal to 1.21 plus J 5.55. That is I1 is 1.21 plus J 5.55. That is the I1 current. Now I2 current is, that is equal to I into Z3 Z1 by summation of Z1 Z2, sigma of Z1 Z2. So that is 10 plus J0 into 26 plus J7 divided by 59 plus J2, that is equal to 4.36 plus J 1.33. That is the I2 current. I2 current is 4.36 plus J 1.33. Now I3 is equal to I of I into Z1 Z2 by summation of Z1 Z2, that is 10 plus J0 into 27 plus J24 divided by 59 plus J2, that is equal to 4.43 plus J 4.22. So I3 is 4.43 plus J 4.22. Here now Z is parallel. That means summation Z1 Z2 Z3 divided by Z1 Z2 plus Z2 Z3 plus Z3 Z1, that is equal to, so here Z1 Z2 Z3 is, what is that? Z1 Z2 Z3 is Z1 is 2 minus J5 and Z2 Z3 is Z2 Z3 is 6 plus J33 divided by Z1 Z2 plus Z2 Z3 plus Z3 Z1 is 59 plus J2, that is gives the, that is equal to, here Z is equal to 3.01 plus J 0.51, that is the Z value. So V is nothing but current into Z. Here current is 10 angle of 0 degrees and Z is 3.05 angle of 9.6 degrees, that is equal to 30.5 angle of 9.6 degrees. The power factor is cos of 9.6. Combination of power factor is cos of 9.6, which gives the 0.986 lakh. 0.9686 lakh. Here, the combination of power factor is 0.986 lagging. So now, go for another problem. Now go for another problem. So here, two impedances given. two impedances are given. Zn is equal to Zn and not Zn, that is Z1. Z1 is equal to 10 plus J5 and Z2 is equal to 8 plus J6. Here 10 is the resistance, J5 is the XL value and 8 is the resistance and J6 is the XL value. These are joined, Z1, Z2 are joined in parallel and connected across a voltage of V is equal to 200 plus J0. Calculate the circuit current, its phase and the branch currents. Calculate the circuit current, its phase and the branch current. Draw the vector diagram also. See, observe this one. Observe this one. Figure. Observe this one figure. So I1 is in Z1, I2 is in Z2. Z1, Z2, Z1, Z2 are parallel, and the supply voltage is parallel across this one. So here solution is so branch A or branch 1, whatever the notation. So branch A is impedance is Z1. So we are going in another method, that is the admittance method. So what is admittance? Y. Y is nothing but it is the reciprocal of impedance. Reciprocal of impedance. So now here in branch A determining Y1 and in branch 2 determining the Y2 and overall admittance also Y1 plus Y2. So why this is in parallel Y1 plus Y2, which gives the total admittance. So in branch A Y1 is equal to 1 by Z1, that is equal to 1 by 10 plus J5. They did not written here plus. So 1 by 10 plus J5. See here, numerator and denominator is divided with the, here see here, observe this one. 1 by Z1 is 1 by 10 plus J5. So here numerator and denominator is multiplied with the 10 minus J5. So Y1 is equal to 10 minus J5 divided by 10 plus J5 into 10 minus J5. That is 10 minus J5 divided by 100 plus 25. Here Y1 is equal to 0.08 minus J 0.04 Siemens. Branch B or branch 2, Y2 is equal to 1 by Z2. 2 is equal to 1 by z2. That is equal to 1 by 8 plus j6. Here, once you observe this one, 1 by z2, it is 1 by z2 is equal to 1 by 8 plus j6, that is equal 8 minus j6 divided by 8 plus j6 into 8 minus j6, that is equal to 8 minus j6 divided by 64 plus 36. That will give 0.08 minus z 0.06 Siemens. So y is equal, in generally, we can say that y1 plus y2. Here, y1 is 0.08. This is the y1. 0.08 minus j 0.04. This is the y1. And y2 is, this is the y2. 0.08 minus j 0.06. This y2 and the above y1 both are added in parallel condition. So here this is the admittance. So we can adding these two y1 plus y2. The total admittance y is equal to 0.08 minus j 0.04 plus 0.08 minus j 0.006. Here 0.08 is the conductance of branch 1 or branch A, and 0.08 conductance of the branch 2 or branch B. These two are added, that is 0.16. So now minus j 0.04 is susceptance and minus j 0.06 is the susceptance of branch 2. Here branch 1, branch 2 susceptance are added. So that is minus j 0.1 Siemens. So here this is by admittance method. We can adding the admittances of branches 1 and branches 2. So now direct method, we could have found total impedance straightway like this. So 1 by z is equal to 1 by z1 plus 1 by z2. That is equal to z1 plus z2 divided by z1 z2. That is y is equal to z1 plus z2 by z1 z2. So here 10 minus, not 10 minus, 10 plus j5 plus 8 plus j6 divided by 10 plus j5 into 8 plus j6, that is equal to 18 plus j11 divided by 15 minus j100. Realization of the above circuit, rationalizing the above circuit, 18 plus j11 into 50 minus j100 divided by 15 plus j100 into 50 minus j100, that is equal to 200 minus j1250 divided by 12500, that is 0.16 minus j0.01, same as before that what we get here y. So in these two methods we got the same value, and these two methods we got same value. So v is equal 200 angle of 0, 200 angle of 0 degrees. That is nothing but 200 plus j0. So I is equal to current. The total current is equal to V into Y. That is equal to 200 plus j0 into 0.16 minus j.1. That is nothing but 32 minus j20. That is equal to 37.74 angle of minus 32 degrees. So here 32 minus j20 is in rectangular, will convert into 37.74 of minus 32 degrees is in polar form. So now 32 degrees is the phase angle between the voltage and current. The power factor is cos of 32 degrees, that is 0.848. It is the lagging power factor. Now I1 is equal to Vy1. What is the voltage V? 200 plus J0 into Y1 is 0.08 minus J.04. That is equal to 16 minus J8. That is equal to 17.88 angle of minus 26 degrees 32 minutes. So now it is lagging behind the applied voltage by 26.32 minutes. So now I2 is equal to V into Y2. That is equal to 200 plus J0 into 0.08 minus J.06. That is equal to 16 minus J12. That is equal to 20 angle of minus 36.46. Here it lags behind the applied voltage is 36 degrees 46 minutes. Here the vector diagram is shown figure. The vector diagram is shown figure. Here the voltage is V is taken as reference V, and the current I1 is lagging by 26.32 degrees, and I2 is lagging by 36 degrees 46 minutes. This I1 and I2 will give the resultant is so 32 degrees angle between the voltage and resultant current. So here voltage and current between the angle is resultant 32 degrees. So this is the phasor or vector diagram in the given figure. What they are given, once again I will repeat here. I am repeating here. So in this circuit, Y1 and Z1, Z2 are given, voltage is given. So we can calculate the Y1 from the branch 1 impedance. Reciprocal of impedance is nothing but admittance. So V1, Y1 is equal to 1 by Z1, that gives the Y1 value, and Y2 is equal to 1 by Z2, that is equal to Y2. So Y is equal to Y1 plus Y2, that gives the Y, that means conductance and susceptance. Here in direct method we could find out the total impedance, that is 1 by Z or 1 by Z admittance. In this way 1 by Z is equal to 1 by Z1 plus 1 by Z2, so which gives the direct Y value. So in the first case we are determining the Y1 and Y2. After that adding, here we can calculating finding the direct y value. So both are same. So from this connect we can calculate current I and power factor I1 from the branch 1 and I2 from the branch 2 admittance, I1 from the branch 1 admittance. So this will give the results. This will give the result current I1 and I2. This is the phasor diagram. This is a phasor diagram drawn here. Vector diagram has drawn. Vector diagram has drawn. So I1, I2 resultant is I. So that is the resultant current I lags by the 32 degrees with respect to the voltage V. So now from this vector diagram we are calculated the I1, I2 and I. So this is the answer for this question. So